today's lesson. So let's see how it works. All right, now I think let me see whether it's, yeah, now it's better. Okay, just now I put the setting as HD video, so it takes time for it to actually record. Anyway, so we will start today's lesson. So you have this reaction, sodium with water. Okay, sodium reacts with water to give you hydrogen. So they want you to write down the gas, okay, that is formed. Now, potassium hydroxide react with water, they just dissolve, so there is no gas that is going to be given. And then sodium carbonate, they just also dissolve, okay, just like that, there is no gas that will be given. So what we need to do over here is actually we need to find out what is going to be the reaction of phenol. Okay, now we have phenol over here. The reaction of phenol with sodium. And if you look over here, I have actually written the some of the things. Okay, if you have phenol react with sodium, it will give you a phenoxide ion and then also hydrogen gas. So therefore here we have hydrogen gas. And then we also here we have potassium hydroxide. Okay, potassium hydroxide, phenol, okay, will react like acid. Okay, you are going to actually get the salt and water. So in this case, there is no gas that is given off. So just put the X over there. For reaction of phenol, okay, reaction of phenol, do remember phenol can react with the metal, and then it can react with the metal hydroxide. It means the potassium hydroxide, sodium hydroxide. But when it comes to sodium carbonate, okay, it doesn't actually the strength of the acid of the phenol is not good enough to react with carbonates to give you salt, carbon dioxide, and water. So therefore, there is no reaction. So there is no reaction. If you want, you can actually refer to the notes that I have actually written over here. Now, the next part is going to be the reaction of carboxylic acid. So the notes I wrote it over here. Okay, the carboxylic acid, okay, when they react with sodium, okay, similar reaction will give you a salt, okay, carboxylate salt, and then they will actually give you the hydrogen gas. It's something like acid react with metal. So you are going to get hydrogen gas. But when you react with KOH, there is a reaction. You are going to get salt and water, but there is no gas that is going to be formed. For sodium carbonate, yes, carboxylic acid can react with sodium carbonate. So they will actually give you the salt, carbon dioxide, and water. So in this case, you just put the carbon dioxide gas over there. Now, this is going to be, it's not actually a phenol, okay, because there is absence of benzene ring over there. So what we are going to do is, this one is just, we are going to consider this, okay, if this is carbon, this is hydrogen, this is one R group, another R group. So it's considered to be a secondary alcohol. So here I wrote a note over here, secondary alcohol. Generally, all alcohols, okay, they react with sodium, okay, to give you the salt and hydrogen gas. So I'll put a hydrogen gas over there. But alcohol, they do not react with potassium hydroxide. Okay, there is no reaction. Mute. Okay, I'll mute everyone. Okay.
Sir, you also mute yourself, sir.
Yeah, just mute yourself. Sir, I cannot hear what you're saying.
Okay, so okay, all right. Okay, now here, okay, so you have a look here, okay, this one ROH, okay, alcohol with sodium carbonate, there is no reaction also, okay. So
Sir,
if you want to
question.
yeah, yes.
Why phenol don't react with Na2CO3? I thought
it is
acid plus metal carbonate gives CO2.
Yes, it will give you CO2, but when it comes to phenol is not a very strong acid, so they are special case. So they are able to react with sodium. okay, but they are able to react with sodium hydroxide or potassium hydroxide. But the moment it comes to sodium carbonate, they are not good enough to react with sodium carbonate.
So they only react with metal and hydroxides.
At hydroxides, yes. You can refer to the textbook. And phenol also react with bromine in excess condition also. So there are some reactions only for phenol. Now, for alcohol, okay, you can actually have a look at, if you go to my BBS Speak channel, I did some kind of summary for alcohol, okay, since we are talking about alcohol over here. There are a few reactions, okay, 6 reactions in your syllabus, AS, combustion, alcohol can only undergo complete combustion, nucleophilic substitution, HCl, PCl3, PCl5, SOCl2, and then we also have PI3, PBr3. I want you to go and read about this. We also have esterification. We have reaction with sodium, okay? And then we sodium or any other metals, lithium and so on. Oxidation reaction, and then dehydration reaction. Dehydration, it will change the alcohol into alkene. So you need to also know what are going to be the catalysts for the dehydration and so on. Okay, dehydration, you need to use Al2O3, or you can use concentrated sulfuric acid, you can use concentrated phosphoric acid and so on. Please go and read about this. If you're using those acids, it's going to be 170 degrees Celsius. In the textbook, they are not so clear on this catalyst for dehydration, okay, because they put the concentrated acid into the question, check for understanding question, I think. So you just have a look over that. Now, here, I'll just go on. Okay, they say that compound C is responsible for aroma of apples. Basically, we are talking about ester. Okay, so if you look at here, there is ester over here, ester bond. Now, it can be prepared for using 3-step synthesis. So here, when we look at the 3-step synthesis over here, the only byproduct of step 1, okay, this is going to be step 1. You can see that something is going to be attached, okay, to position number 1, 2, 3, 4, position number 4, because of the OH is going to be 2, 4, 6 directing. Yeah. Now, at position number 4, okay, this particular alkyl group is attached. So this one you need to know is going to be a Friedel-Crafts alkylation. So in order to do that, you need to have a halogen carrier. So this is going to be the carrier. So AlCl3 is the catalyst. So you can actually do this Friedel-Crafts acylation or alkylation using the same catalyst over here. So if I take this part, okay, I just need to put over here. So this one is going to be, I put the Cl over there. So it will react with the phenol, okay, to give you this reaction. So they ask you to suggest the region. If I suggest the region, I will just put it as C, and then there is 3 CH3, so I just put CH3, and then there's 1 Cl, and then region, so you can actually leave this alone, or if you want to include the catalyst, you just put the NaLCl3 as catalyst. It's okay. Now, what type of reaction is occurring in step number 2? Okay, if you look at step number 2, the benzene ring over here, they are disappearing. It means some sort of if you put it as double bond, yeah, okay, even though it's not accurate, what happens is the double bond is going to be kind of disappear. So this one is going to be something like an addition reaction. So what type of reaction is occurring in step 2? You cannot put addition reaction, okay, because it's not suitable. So rather than putting as addition, so probably the double bond, the carbon-carbon double bond, is kind of reacting with H2, where the double bond is broken, and then you have H and H. So this one, we can actually put it as hydrogenation. Hydrogenation will be much more suitable for this. Is that okay?
So you can say electrophilic addition or no?
Electrophilic addition will not be suitable for this.
How about reduction?
You can actually put reduction. Okay, I'll just reiterate the electrophilic addition. Now, any benzene, okay, do remember they will not undergo electrophilic addition. This one's supposed to be going through nucleophilic what?
Not electrophilic sub.
No. So it's supposed to actually undergo nucleophilic addition. Okay, because under electrophilic addition is more towards carbon-carbon double bond. So in this case, it's just similar to that, but they will not undergo electrophilic addition because of the benzene structure. So do not actually give your answer as electrophilic addition. So the answer that is suitable over here is either reduction, or you can actually put it as a hydrogenation. So hope it's clear. So do not actually put it as a addition reaction. Addition reaction is not suitable for this kind of a molecule. Okay, hydrogenation would be the best. Okay, hydrogenation. Now, what regions and conditions are required for step number 3? Now, for step number 3 is going to be you are changing. Okay, you are changing this part. Okay, to something like this. So it means the alcohol or the phenol is changing into something like a ester. So it means I definitely need to react with carboxylic acid, so that alcohol react with carboxylic acid to give you ester. So esterification reaction is going to happen. So I have written over here, probably you can see over here. So this is going to be the phenol, my B. Okay, this is B. And then I need to have this molecule. Okay, this molecule to come over here. This is going to be my carboxylic acid. So what I need to do, I just need to put the OH over there. So that's why I put the OH over there. So in this case, what region required for step number 3? So I need CH3 COOH. Okay, I need that. Okay, so this is C actually. Okay, CH3 COOH. And the conditions, okay, because this is esterification, so you need to heat under reflux. And then is there any other condition that you need to include, Aditya? Aditya, are you there?
Concentrated HCl.
H2SO4. Okay, H2SO4 will be more suitable. Okay, so concentrated HCl or H2SO4, according to your syllabus, is concentrated H2SO4. Now, for state the region and condition needed to convert C back to B. So you want to actually change this back to here. It means now you're changing ester, okay, and going back to alcohol. So this is going to be hydrolysis reaction. So we have two types of hydrolysis reaction. It's either acid hydrolysis, or you can actually use base hydrolysis. Yeah. So in this case, do remember you want to change it into OH. Okay. So if you are using base hydrolysis, okay, what happens over here is you are not going to get the OH. Okay, it means do remember, if I have hydrolysis, I'm going to actually get ester change into carboxylic acid plus alcohol. Now, do remember, if I use NaOH, NaOH will actually react with carboxylic acid to give you carboxylate ion. If I use ACl or any acid, acid will react with the alcohol, okay, to give you the, it will give you the, sorry, acid. If you have carboxylic acid, okay, this one will react with the NaOH. If you have alcohol, okay, ROH will react with the HCl. Will it react with HCl? No. Okay.
No.
So what is going to happen? You need to be very careful for the hydrolysis. So if you want, okay, do not use the base hydrolysis, okay, because base hydrolysis is going to actually make the alcohol change into, okay, a salt. So what I'm going to use, I'm going to actually use acid hydrolysis. So hydrolysis, so you can actually use any acid. So better according to your syllabus is HCl, and it's a hydrolysis. So it's better to actually write it as a dilute. Okay, hydrochloric acid dilute and heated. Okay, and heated. So you will actually have the hydrolysis over there. So please have a look at the hydrolysis part. Okay, you need
Sir,
to
but
actually learn
base
about that.
doesn't the NaOH doesn't react with the alcohol, right?
NaOH, okay, they do when it is going to be with phenol, okay, for phenol they don't react.
This one also don't react, right?
Sorry,
With B.
for
don't
phenol
react.
they react.
They
They
react.
react. They react.
Huh?
Okay, they react. Here, phenol, they react with KOH. So it means here, if you use NaOH, what happens is they will give you a salt.
Oh
So
yeah,
it's
yeah.
not suitable. Okay, it's not suitable.
But here
So
comes cyclohexane, not phenol.
Where?
B. Move up, sir. Yeah.
This one. Oh, this one is going to be a normal alcohol. So if you look at alcohol, when alcohol,
Don't react with NaOH, right?
yeah, they don't react with NaOH. Okay, they don't react with NaOH. So basically, you can also use the sodium hydroxide also. Yeah, you can actually use sodium hydroxide also because they don't react.
Okay.
So you can even actually use the sodium hydroxide and heat it. So that's why I thought it's actually phenol. Okay, you can actually use dilute HCl, or you can actually use the sodium hydroxide solution, okay, and heat it also. So both, okay, but be careful next time. If it is going to be there is a phenol, then be careful. Now, read about the hydrolysis reaction, okay. Now, the next question over here is, okay, either compound A or B, okay, or both, okay, they can react with the following reagents. So they ask you to write the structure of the organic product formed from A and B. So what is going to happen over here? So we want to actually see what we will get, okay. So here is going to be, you have BR2. So I've actually put the A over here and B over here so that easier, we can see it easier. So when you have excess of BR2, okay, take note the OH, okay, the phenol is 2, 4, 6 directing. The position number 1, 2, 3, 4, 5, and 6. 4 is already taken, so probably you will have this structure, and then you have the BR. You have the BR over there. Okay, you have that. Now with B, okay, with B, what is going to happen over here? This is going to be alcohol. Alcohol, they do not react with Br2. Okay, they do not react with Br2. Okay, in this case, so what's going to happen is going to be there is no reaction. Okay, take note that reaction of alcohol. Okay, these are the reactions of alcohol. Now, so no reaction. So when you heat with HBr, okay, do take note HBr. When you heat, okay, the phenol don't have any reaction with HBr, and then without the presence of any kind of a halogen carrier, it cannot just go inside the ring also. So here will be no reaction. But when you have HBr, okay, for alcohol, so you take note at nucleophilic substitution. So there is going to be a substitution reaction going to happen. So you just need to change this structure to Br. So if I actually put it over here, let's see. Copy. And then I just need to actually put it as, okay, this one will be. Okay, I just need to put this as Br. Okay, that's going to be the answer. Now, when you put the vapor over heated Al2O3, this is going to be dehydration reaction, and it comes under the reaction of alcohol. Okay, got nothing to do with this. So here will be no reaction. And here, there will be a dehydration reaction going to happen. So what's going to happen is there will be one H over here. So this one will be dehydrated. So there will be a presence of double bond over there. okay, you can actually put the double bond either here or double bond over here. It's the same. Okay, you can actually dehydrate over here. So this one is going to be dehydration reaction. So the answer will be something like let's see when I put here. Okay, so I just need to put a double bond over there. That's going to be my answer. Now, heat with acidified K2Cr2O7. Okay, this one is going to be an oxidation reaction. So this for phenol doesn't undergo oxidation reaction. So we are talking about the reaction involving alcohol. So here, okay, we know that this molecule, okay, is going to be secondary alcohol, 1R group, 1R group. Okay, that's 1H. So it's a secondary alcohol. So secondary alcohol here, okay, if you do oxidation, they will change into ketone. So when they change into ketone, I think better if you just put something like this. If I just draw. So double bond, oh, that will be ketone. Can you understand?
Yeah.
All right. Now, the last question over here is, okay, choose one of the above reaction to enable you to distinguish between A and B. So you need to find out which one is A, which one is B. So here, the best answer over here is to get a reaction, because you see, you can use any of this reaction to distinguish, but you need to have some kind of solid observation where you can actually see something. Okay, the one suitable here is going to be Br2 is orange. Okay, so you can actually use the first one, orange, and this one you can read also. This one actually gives you a precipitate, a white precipitate actually. So you can say the brown color will be decolorized, and then there will be a white precipitate will be formed. Or, okay, if you want to actually choose another one type of reaction, I will suggest you to use the fourth reaction using K2Cr2O7. Okay, you will definitely see a reaction for this, okay, where the reaction will change from what color to what color. If let's say I'm using this reaction. Yeah, Angie, what color to what color if I'm actually using this?
Wait, orange to green.
Okay, so you will actually have, okay, the reaction is going to be orange to green.
Orange to green.
So here
Okay,
will be
let's
no
stop it.
reaction. Okay, do you have any question?
So I need to screenshot.
Sir,
Probably I'll send
Sir.
a PDF copy of this. Yeah.
Okay,
Yeah.
thank you.
why the phenol cannot oxidize?